In mid-2022, the James Webb Space Telescope began its primary mission around 1.4 million kilometers from Earth. As the successor to Hubble, Webb was expected to search for the oldest light signals in space. Originally, it was anticipated that Webb would gaze back to the origins of the universe. However, just hours after the first images were released, it became clear that Webb was not just seeing the beginnings of the universe. Instead, it was capturing images that challenged our previous cosmological view. Amid all the excitement, one discovery nearly went unnoticed. In March 2022, when groundbreaking revelations seemed rare, the old Hubble telescope astonished scientists by capturing an image of a star that became known as Earendel. Earendel is the oldest single star ever observed by humans. Learn more about Hubble, Webb, and the Star of Dawn in this video. Before we share these exciting details, we invite you to leave a comment at the end of the video. Let us know your thoughts on this and the latest findings in cosmology. In the future, we will reward our subscribers' contributions with a heart, and we'll pin your meaningful comments to the top so everyone can read them first. Be sure to subscribe and like the video, and mention both at the start of your comment. We're looking forward to hearing from you, and now, let's dive into the story of Earendel, the oldest star ever observed by humans. A stunning discovery. The world was already eagerly anticipating the Webb mission when astronomer Brian Welch from Johns Hopkins University announced something astonishing. In an image captured by the Hubble Space Telescope, scientists identified the oldest single star ever found. Initially, this object was given the technical name WHL0137LS, but soon after, it became known worldwide as Earendel. The name Earendel originates from Old English, meaning morning star or rising light. If you're familiar with the works of J.R.R. Tolkien, the name might sound familiar. In Tolkien's stories, Earendel is the morning and evening star, whose light grants immortality to the elves. Somehow, this mythical name is fitting for a star that has been dated to around 12.9 billion years old. In March 2022, researchers were already aware that this star existed approximately 900 million years after the Big Bang. At the time, scientists still believed that Earendel was one of the earliest single stars independently scattered across space after the Dark Ages. Earendel's ancient light was visible only due to a phenomenon called gravitational lensing. The gravitational forces of the galaxy cluster WHL0137-8 amplified Earendel's light so much that the star became visible despite its enormous distance. This effect is comparable to moving a curved magnifying glass over a map, where individual sections are highly magnified. The galaxy on whose edge Earendel was discovered was named the Sunrise Arc. Experts believed that they had found a step toward the cosmic dawn with this discovery until Webb arrived and changed everything. Webb shakes up old theories. If you follow our channel regularly or love astronomy, you already know that the cosmic view has been under scrutiny since Webb's first images. The James Webb's Deep Field image revealed so many ancient galaxies that the Big Bang theory currently appears increasingly unlikely. At least not in the way it was traditionally understood to have occurred 13.8 billion years ago. Webb didn't just reveal galaxies that, according to previous cosmological theories, shouldn't exist. It also gave us a new look at Earendel. In the Deep Field image, Earendel appears as a tiny point of light. You can also see a ring of light in the image that scientists call the Sunrise Arc. The brightly shining star in the image is much younger than Earendel, evident from the blue-white light it emits. The brightest objects are the youngest and closest, while the red, dim, and somewhat blurry light signals come from the oldest objects in the universe. Thanks to this image, researchers were able to get an even better picture of the Dawn Star. Earendel's mass and likely fate. Earendel likely had a mass between 50 to 100 times that of our Sun, classifying it as a blue giant star. It's fitting to use the past tense because Earendel likely no longer exists today. The lifespan of the first massive blue giants was probably under 4 billion years. If the star still existed today, it would be about 28 billion light-years from Earth due to the expansion of the universe, making it undetectable even by the James Webb Telescope. Earendil's light traveled 12.9 billion years before it reached the James Webb Telescope in the summer of 2022. In analyzing this light, scientists were able to uncover new insights into the star's nature. Webb observed Earendil through 8 different filters, each highlighting various aspects of the light. Determining Earendil's age. Astronomers estimate the age of stars based on the so-called redshift. During its journey through space, a star's light is stretched by, among other factors, the expansion of the universe. The longer the wavelength, the more the light shifts toward the red end of the spectrum. The redshift of Earendil is 6.2, corresponding to an age of 12.9 billion years. Before this discovery, the stars with the highest redshift that scientists had detected were in the range of 1 to 1.5. The extraordinary brightness of Earendil. Webb revisited the brightness calculations and came to a clearer conclusion than Hubble. According to the latest findings, Earendil was a Type B star with a strong surface temperature of 12,000 to 15,000 degrees Celsius. These stars are not the largest or hottest in the universe, but they are brighter and hotter than our Sun, a G-class star. The luminosity of Earendil may have outshone our Sun by up to 1 million times. It likely had a mass that exceeded our Sun's by a factor of 50. Currently, astronomers can't say with absolute certainty that Earendil is a single star. The light may have also come from a binary or multiple star system. The few massive stars still in existence today often have smaller companions or are in multi-star systems, likely because these massive stars have such a strong gravitational pull that they attract other stars. Astronomers estimate that Earendil is 1 million times brighter than our Sun. This luminosity bumps up against the Humphreys-Davidson limit, the known luminosity threshold for celestial bodies. If Earendil truly is a single star, its brightness could require astronomers to adjust this limit. A glimpse into the first stars of the universe. Cosmologists consider Earendil a population 3 star, representing the first generation of stars in the universe. Formed from the primordial elements hydrogen and helium through a process called primordial nucleosynthesis, these stars were likely giants like Earendil, with only trace amounts of metals. In astronomy, all elements beyond hydrogen and helium are considered metals. Most of these population 3 stars have likely died out, their lifespans possibly lasting only a few 100 million years. Webb's discoveries offer a new window to potentially find more ancient stars in the future. What the future holds. As mentioned at the beginning of this video, the James Webb Telescope has already identified several galaxies that defy current age assumptions. These galaxies suggest the universe may be older than previously thought, or that its beginnings occurred differently than cosmologists once believed. Galaxies that are 13.6 billion years old already existed 200 million years after the Big Bang and exhibit mature, luminous, and massive properties. Following traditional Big Bang models, only individual stars should have existed at this time, not well-formed galaxies. Earendil, at 12.9 billion years old, is no longer considered as ancient as initially thought. Though it remains difficult to detect individual stars within these ancient galaxies, Webb's future images, aided by gravitational lensing, could lead to the discovery of even older stars. What do you think of Earendil's discovery and the latest findings from the James Webb Telescope? Do you believe Earendil was a star from the universe's early hours, or do you suspect our assumptions about the universe's age may be incorrect? We'd love to hear your perspective. Don't forget to mention your subscription if you have one, and like the video. Thank you for joining us today, and we'll see you next time on Spaceverse.